But what's pretty exciting is we actually already have quantum computers today. You can communicate with a quantum computer just with a credit card and using a cloud platform. But the quantum computers that we have available to us today, technically they're described as noisy intermediate scale quantum computers. So they're kind of small in the scale of the quantum computers that we imagine that are going to solve potentially really valuable problems in the future. So you asked about how long. So we think we're probably in the scale of 5 years away, perhaps, from maybe a smaller scale error-correcting quantum computer, which is sort of the next step in quantum computing that will actually be able to solve sort of commercially valuable problems. And then more likely in that 10-year time frame, where we truly get the scaled error-correcting quantum computers that perhaps then threaten the security of some of the world's digital information. But it's definitely an exciting space. I mean, Microsoft announced their Majorana 1 chip, Google their Willow chip, the IBM Quantum platforms is showing some rapid development. So it's definitely a space where we're seeing more and more progress happening almost every week that passes. Well, I'd say it's hard to answer that any other way than to say, no, we're not prepared. And to me, it's a pretty urgent call to action. And we are seeing some of that urgency reflected in some of the latest guidance. Just a few months ago, NIST released some updated guidance where they added a 2030 date. In their previous guidance, they said all U.S. federal systems had to be migrated to quantum-safe cryptography by 2035. They added a 2030 date in their last guidance, which really asked for all new systems deployed in the US federal government to be deployed with quantum-safe cryptography. So it's sort of a deprecation date. So traditional public key cryptography deprecated in 2030, totally forbidden by 2035. And we saw some similar, more urgent guidance coming from other jurisdictions too. The UK just updated their guidance. Australia did the same. So we're starting to see some of the world's most knowledgeable organizations on the topic of cryptography starting to push their guidance up. And I think what's behind that is this ongoing incremental progress, but also a recognition of how long it's going to take us to transition existing systems to quantum safe. So from my point of view, there are some critical things organizations can and should do today because this transition is going to take some time and dollars and effort. I talk to my customers a lot about three things. Find your cryptographic assets, control them with policy, and automate the lifecycle management of those assets. And those kind of three, to me, form that secret sauce of how we can respond to this quantum threat. And the nice thing about all three of them is I didn't talk about, support post-quantum cryptography, make sure all of your technology is updated, make sure it supports PQC. Those three items, find, control, and automate, we can make significant progress on right now with technology we have available. We just talked about that inventory step, and that's often like one of the starting points for most organizations. Hey, how can I find my cryptographic assets, my keys, certificates, and secrets? I'm actually seeing organizations kind of getting stuck there. They're finding and realizing it's hard to find them all and sort of getting stuck in that process. Thinking of the journey to quantum safe a little more in parallel, that not only can and should you be working on your cryptographic inventory, but it's only really now or within the last few months that you can implement post-quantum cryptography in your infrastructure today with sort of a production posture. So this isn't wasted effort. You can deploy things like HSMs and PKI with standards-based, in the firmware, compliant versions of the NIST post-quantum algorithms. You can issue PQ certificates out to endpoints. And there are some technology platforms and places where you can actually implement PQ in production today. So that concept of post-quantum cryptography now, I think, is an important one. And you're not actually improving the security posture of your organization until you get to the point where you can actually implement PQ. And we're just sort of at the point now where the leading organizations in the space are actually moving towards that PQ now kind of mindset. So one of the starting points for me is just the general cybersecurity frameworks and guidance that are out there, things like Zero Trust or NIST CSF. And those frameworks talk about encrypt all of your information and strongly identify all of your devices and people. And what that's doing for organizations is really exploding the number of cryptographic assets, keys, certificates, and secrets that organizations have to manage to do that, to encrypt all their data and identify all of their devices. Then if you look at sort of more specific guidance, things like HIPAA or SOX or the GDPR and the California Consumer Privacy or even ISO 27001, some of the vertical specific stuff like DORA or NIS2, they start to get a little more technical again and talk directly about implementing adequate and effective use of cryptographic controls, or you have seen words like recognized and approved cryptographic mechanisms. So these compliance frameworks are pretty clear. You've got to encrypt all of your information, and you have to do it following cryptographic best practices. And what cryptographic best practices are moving towards is PQC. So in order to be compliant with some of these guidances, and within the next few years, you're going to have to be using post-quantum to be adequate and effective, or recognized and approved, like some of those words that you pull right from those compliance guidelines. So we're definitely seeing industries and verticals where compliance regimes are important, perhaps moving first and fastest towards post-quantum.